Hello, this is Jennifer Dassinger with A Plus College Ready, and I'm here today to talk with you about general equilibrium and its basics. So, equilibrium is where the rate of the forward of the reaction is equal to the rate of the reverse. This is where the concentrations of your reactants and products will remain constant once equilibrium is established, and equilibrium is temperature dependent. So if you notice in this graph over to the right, the rate of the reactants is decreasing as the rate of the products is increasing. But then if you notice concentration, more importantly, the concentration of the reactants are decreasing and the concentration of the products are increasing. And these are affected by concentration of the quantities of the reactants and products, your pressure, if they are gases, and temperature. So again, three major factors. Concentration. Obviously, think back to your states of matter, kinetic molecular theory. When you have more concentration of a reactant, there's going to be more initial collisions, more effective collisions. The faster the reaction will go from reactants to products. However, if the products have more concentration, then the reaction will shift from the product side to the reactant side. Think also too in terms of energy. Think back to thermochemistry. If the reaction is endothermic, the heat will be as, quote, on the reactant side. And if heat is applied, it'll shift towards the reactant side. If the reaction is exothermic, heat will, of course, shift towards the product side if it's added into the reaction. Energy. Think also too in thermochemistry, we had entropy, and everything in nature tends to normally thermodynamically favored of delta S is going to be positive from maximum order to disorder. So when K is greater than 1, the reaction is going to shift to the product side, or we say to the right. This is where you're going to create more product because there are less concentration of them. If K is less than 1, that means, of course, that the reaction is going to shift to the left. That is favoring the reactants. And if you notice, again, the amount of the reactant and product does not have to be the same. When K is equal to 1, that, of course, means that roughly they have equal concentrations and the reaction is said to be at equilibrium. Now, remember again, K is temperature dependent. However, it does not change with concentration or pressure. So remember your standard conditions, 1 atmosphere, lab settings of 25 degrees Celsius. The law of mass action is where you write your equilibrium expression, aka your balanced reaction, and you put your concentration of your products raised to their coefficient over the concentration of the reactants, raised to their coefficients. Now the good news is that there are no units for K. She's special, she's naked. So naked number on her. But there are lots of different Ks. So we've got to pay attention to our question, what we're being asked to look for. Are we looking for Kc, that is the equilibrium expression for concentration? We would indicate that by writing our concentration of our products and reactants in bracket form, which stands for molarity. If we're asked to write an equilibrium expression for pressure, though, different. That is things that are given to us in atmospheres, and those will be in gaseous form. So therefore, our concentration is not going to be written with brackets, but in parentheses or with a P for our law of mass action. We're going to practice here in a minute. And don't forget, most importantly, that pure solids, pure liquids, and pure gases will not be found in your equilibrium expression. So here's an example. You're given a balanced equation. Notice that the solid of tin 2 oxide is pure and 10 is also on the product side is in solid form. So therefore, it will be left out of your equilibrium expression. So therefore, your carbon dioxide product is raised to its 2 coefficient over the carbon monoxide reactant raised to its 2 coefficient. Here's another example. Notice again, water is left out of your equilibrium expression because water is pure. And since it really has no concentration, it will not affect the overall chemical reaction. So therefore, it's left out due to it has really no concentration value. Now it's your turn. At this time, if you'd like to pause the video and attempt these 3 practice problems on your own, I highly recommend you do that at this time. However, if you're pushed for time and just want to review, you can go ahead and continue on. So just a minute and we'll come right back. All right, I guess you've returned. Now you're ready to check your answers. So for practice problem number 1, notice that when we are asked to write in concentration form, we have our products over reactants raised to their coefficients. Now, if you were asked to write that for the pressure, there's actually 2 ways that you could write that. You could just put it in parentheses, raised to the coefficient, or Kp is where you have P pressure of your nitrogen dioxide raised to the 4, your P pressure of your water raised to the coefficient of 6. Those are your products over your pressure over your ammonia raised to its coefficient of 4, and pressure of oxygen raised to its coefficient of 7. Then if you notice the answer for number 2, it's basically just chlorine. And then in concentration form with brackets, in pressure form, it is a P in front of the chlorine in parentheses. Same thing with number 3. If you're dealing with concentration, again, molarity, it's in bracket form. But if they ask you for pressure, you need to put it in parentheses with a P in front of the substance, raised to its coefficient. And that is all I have for today for general equilibrium basics. If you can balance a reaction, write a reaction, write your law of mass action with your equilibrium expression of your products over your reactants raised to its coefficients, you're already halfway there. That would be an A or a B part on an FRQ at this time, and several multiple choice questions. So don't forget, when K is greater than 1, the equilibrium expression is going to be product favored. If K is less than 1, then it's going to be reactant favored. The equilibrium reaction will shift towards the reactant side. We'll see you back for equilibrium calculations.